Hello everyone and welcome to this course on modern application development. Okay, so now that we have seen the basic components that you need in order to deploy an app, let's understand a little bit about what I'm going to call the services approach, right? And there are a number of acronyms that you come across here: SaaS, IaaS, PaaS, right? What do these stand for? Why are they useful? Why do you need to know about them? Right? And how can you make use of some of these techniques is what we are going to look at. And I'll also be showing you a couple of examples. So the service approach essentially says that rather than one person trying to do everything, that is, you build your own computer, you install it somewhere, you provide a UPS, you get a network connection, right? You then monitor it, you install the operating system, do everything on it. It makes sense to sort of specialize, okay? So what happens over there is data center operators then specialize in what's called infrastructure, the physical computers, right? So what they do is data center specialists would say, okay, I can set up a data center. What does that mean? It means that I will have a building. The building will have appropriate cooling and security to make sure people can't just walk in as they like. The building itself will be monitored properly. There will be all kinds of protections against fire and other hazards, right? And then what do I need to do? I need to provide uninterrupted power and a good network connection, right? Once I have that uninterrupted power and a good network connection, it means that I can just put a bunch of computers out there. I don't care what's running on those machines. I don't know what's running on those machines, right? That's for someone else to deal with, right? So the data center operator specializes in just the infrastructure, which means that the developers can now focus on the app, because as far as the developer is concerned, somebody else has taken care of setting up the room, the cooling, the network, the power, right? And you can assume that you have a server which is always on and has a permanent IP address that can be reached from somewhere, and all that you need to do is write your app, okay? Now, you could go one step further than that and say, look, not only am I writing my own app, I might end up using some kind of standardized systems, right? And maybe there is some standard software that others have written, and I want to make it available for other people to use, right? So I just install it, make sure that it's properly set up and upgraded and so on, and others can just use it, okay? So this whole idea of services is that you find out what are all the tasks involved in getting something done, and then find out who can specialize in any given part of the task, okay? So one of the first things that came along over there was the so-called software as a service, right? And software as a service, the examples that you are probably most familiar with are things like Google Docs, Gmail, Google Spreadsheets, Forms, right? Microsoft Office 365, right? And you could also have some kind of content management systems, Drupal, WordPress, right? I mean, there are people who actually host those, meaning that they completely install the software for you. All that you need to do is create an account and use it, okay? So what does that mean? It means that you want to use certain software. You don't want to install everything or run the code or anything on your local machine. Somebody has already set up the system for you. They have got a data center, multiple data centers. They have installed the software. You just need to create an account and, if necessary, pay for it, okay? Now, this essentially is something called hosted solutions, right? You might also find that something like Redmine, which is used for tracking issues, or GitLab, which is used for version control, they have versions that you can install on your own, okay? So you can actually have the entire thing and say, okay, I will install it on my own machine and run the entire thing. The alternative is they will run it for you, right? So gitlab.com, for example, is something that you can directly create an account on and use it. It provides a number of services for you, right? It has the Git interface, it has all these merge requests, pull requests, all of that stuff comes along with the interface, and they make sure that it is kept secure and up to date, okay? Now, the alternative would have been that you could have downloaded it from their website and installed it on your own. The point is that by having all the software installed and maintained by someone else, they are taking care of making sure that it's up to date and everything else is done for you. Now, at the other end, you could have what is called infrastructure as a service, IaaS, right? Infrastructure as a service, since we have been using the word infrastructure to refer to what is sometimes called the bare metal, right, or just the raw computers themselves. Essentially what we would have over here would be virtual machines or the actual physical machines themselves, right, set up in some data center somewhere. Power, networking, etc. are taken care of, but that's it. Everything else is your job, right? From installing an operating system, managing the operating system upgrades, security patches, software updates, all of that stuff is left to you. Pretty much what they say is, look, rather than buying a computer and putting it under your desk, right, and plugging it in, you can just assume that that computer is taken care of somewhere else. But everything else, what you put on it, how you manage it, do you mess it up and make it crash by running bad software on it, all that is your problem. Okay, all that the IaaS provider is doing is giving you a machine with some kind of an interface to control it. There are many cloud compute systems. AWS, Amazon Web Services, was sort of more or less the first one to really start this off in a big way, right? But of course, Google Compute Engine, Azure, Microsoft, right, all of these are big players in this area. But apart from that, there are also some others, DigitalOcean, Linode, and so on. And some of them give you actually better options in terms of price to performance and so on, right? So DigitalOcean has some nice options which can end up being cheaper than some of the Google or AWS offerings, right? A simpler interface and a few other options that actually make it sort of nicer to use in some ways. But it depends. I mean, so Google is not not providing those services because they think that DigitalOcean does a better job. Google could also do it. The point is that they are focusing on other aspects. They have a slightly different way of providing these services to you. So which one should you choose? What should you do if you are trying to do this? It depends. You need to sort of familiarize yourself with a few of these, look at the options, and then decide how to go about it. Now, all of this is assuming that you want to go with the so-called infrastructure as a service. That is to say, you are willing to work with raw machines, right? Somebody just gives you a machine, you will take care of installing everything that you need on it. Okay. So what's the alternative? We can look at something called platforms, right? And a platform is a combination of hardware and software, right? What we are saying is, look, I need hardware of certain capacity. That is, I probably need so much memory, I need so much CPU speed, so much disk space, and so on, right? But why do I need that? Because I want to run a specific kind of software, right? So this particular operating system, right? Maybe Linux Ubuntu 20.04, right? Or the Red Hat Enterprise Linux some version, right? Or maybe Microsoft Windows with some particular version. All of those are different options that you might have as your requirement of what is the software to be installed as part of your platform. In addition to that, you might also say that I want a specific development framework. I need Python, a specific version of Python, right? Or I need Python with these libraries. So for example, I want to develop a Flask application, so I need a specific version of Python, I need a specific version of Python Flask, and a specific version of SQL Alchemy and whatever else is required for my app. Or maybe I'm planning to develop in Laravel, so I need PHP, I need a web server that can interface with PHP, right? All of those things need to be there. So the simple solution, of course, would be you go with the infrastructure as a service approach, get a machine, install whatever you want. The other alternative is to say that somebody will actually set things up for you, all the way up to saying that we will provide you with a web server that has an interface to PHP and this version of PHP, this version of Laravel. Now write your code. All that you need to do is push your code and it will work. Okay. So that is the idea of a platform, and the platform as a service means that the provider takes care of multiple things, not just the power, network, machine management, which is infrastructure. They also do OS installation, security patches, which is part of software, and they provide you with some kind of a base application platform, right? It could be Python Flask, PHP, Laravel. They will manage multiple versions for you, right? Python 2, Python 3, Python 3.8, 3.9, right? Various different things, whatever is suitable, so that you can then decide and say, okay, this is the particular option that best suits my needs. They also typically provide some way by which you can have database connectivity, right? Because you don't necessarily want to be installing and managing your own MySQL database or your own PostgreSQL database, or you might even want to go with something like a cloud-based storage, right? Redis, MongoDB, Firebase, right? A whole bunch of options that are available for you. So what does the developer need to do? manage the application code. You just concentrate on getting your app correct, okay? And then you need to specify to the platform as a service provider what kind of server size you need, what kind of database connectivity you need, and they will give you information about how to actually set things up, okay? And the nice thing over here is, when you have this nice interaction between the developer and the service provider, scaling can also be taken care of by sharing inputs between the two sides, okay? So the developer can say, okay, when do I want to scale, when do I need a new machine, and the provider can say, what are your options? Do you need to deploy a new machine? Can you have a front end that will take care of part of the processing for you? Can you move to a different kind of database? What are all the options that you have with this setup? Okay. So what I'm going to do now is to show a couple of examples, right, of how you could use Replit, which you are already familiar with, but also a couple of other things, and what the interfaces look like and what they imply in terms of deployment. Okay, so this is the Replit interface that most of you should be familiar with. All of you hopefully are familiar with at this point, right? Because you've been using it throughout this course and possibly for other courses in the diploma program as well. And what we have over here is, I've created a very trivial Flask application. It pretty much consists of just this one file, main.py, but there are also a couple of other files, poetry.log. Poetry is a sort of package manager which is used by Replit, okay? And what they do is they pretty much just find out what packages you need and thereby figure out what needs to be installed over here. And the code itself is very trivial. I'm just giving you a sort of dummy example out here. All it says is from Flask import Flask, and I have defined one global variable in this server, x, and inside my main root, which is to slash, right, all I'm doing is that I declare x as a global, do x is equal to x plus 1, and then basically say print out a string, okay, hello Repler and whatever that string is. Then I basically go ahead and run it with name equal to main, okay. What happens when I run this code? So you can see that immediately in the console a few things start happening out here. There are a bunch of messages that pop up saying what is actually happening. It also says this is a development server and so on, right? Do not use it in a production deployment. All good, right? And you can see that at the end of the day it has made a request to get slash, and yes, it ended up creating this particular thing. I had called my REPL Flask test. My username over here is nchandra, and therefore flasktest.nchandra.repl.co comes up out here, okay. So what does it print? Of course it prints out hello Repler plus this string, which is x equal to 1. Now what that in turn means is, if I refresh this page, right, and send one more request to it, it now shows hello Repler 3. Why did that happen? Because of course x, which is sitting inside the server at this point, is a global variable and is getting incremented, right? So every time I hit this page and refresh it, it's basically going to go in there. The server is still alive, right? I mean, the server has, once it was started by Replit, it basically retains its state internally. It doesn't know who is connected to it or where I'm connecting from, but it knows that internally this variable x has the value at this point 4, okay? And every time there is a request to the slash, it has to display this hello Repler and basically increment that variable, okay? So that's what is happening out here. If I copied this URL and went and visited it somewhere else, right, in another browser even, it would show me exactly the appropriate thing, right, hello Repler, and that number would keep on increasing because ultimately all those requests are going back to this same server. So I can in fact do that, right? I can just basically open it in another page out here, right? So as you can see, now this has opened completely in a new Chrome tab, right? And in the top left corner, you can see there's a hello Repler with the value 5 over there now, right? So in fact, if I zoom in a little bit, you can sort of see the text a little bit bigger, right? And each time I sort of reload this page, it's going to show me an updated version of the text over there because it's going back and fetching fetching the data from the same server, okay? Now, what does this mean? When I go back to REPL, I can see that apart from the console, which is showing me all the requests that have come here so far, I also have access to a shell. Okay, and the shell, when I go there and start looking at what is available to me, I realize that this is actually a Linux machine. Okay, so I can type, for example, ls, which tells me that there are 3 files present over here, the same files that are shown on the left hand side, right, in the file manager. And not just that, I can find out a little bit more information about the server as well. For example, I can type the command lscpu, which will tell me, which is a Linux system command, which tells me a little bit about what kind of processors are available on this system, right? And if I scroll up a little bit, I basically find that it's running Intel Xeon CPUs, right? And there are 4 CPUs available for this system, okay? And it also has some amount of memory. The memory that I have over here, by typing in the free command, I find that I basically have 26 GB of RAM, okay, 26,000 megabytes. So in other words, what this is telling me is that Replit, when I tried running this particular code, automatically gave me a machine with 4 CPUs and 26 GB of RAM. Okay, that sounds like it's like extremely generous of them, and it is, right? I mean, it's quite a big chunk of resource to give you. The point is, why they are able to do this is that it is shared. So even though it says 4 CPUs and 26 GB of RAM, the way it gets implemented in practice is that this itself is shared among a large number of users. Okay, and on their data center, you know, the back end of their data center, what they have is a system with probably much more than 26 GB of RAM, but it's partitioned into smaller blocks, which in turn are shared out among multiple users. And not just that, the way Replit works is, the main purpose of Replit is not really to run apps. It's more for education, development, right? I mean, to sort of learn how to build such systems, which means that after you have had the app running for a little while and then it goes away, right, you will find that the app shuts down. Okay, so if I now leave this running without clicking stop, I'm going to click stop because I don't necessarily want it to just be using up resources on the Replit server. What will happen is that after a while, Replit will automatically shut it down. Okay, and at that point, if I then go back to the URL, it will once again start up my server, right, which means my global variable x will be reset back to 1. It will take some amount of time in order to start it up, but otherwise I have the entire thing working the way that I expected it to. Okay, so Replit is one example of a platform as a service, in the sense that you could actually develop Flask apps. The main difference here is its main purpose is not deployment, right? So if you want to actually deploy an app and start scaling it and so on, you will find that it does not really have those kind of resources. Okay, now there is another option which is called glitch. Okay, and glitch.com is something which once again is, you know, they provide a similar kind of interface to Replit, right? In glitch also, the main sort of core idea that they have is sort of to say, okay, let's make the development task easier. Okay, so they provide you, once again, just like Replit, they have this setup where you have a file manager. You also have access to the web interface, or rather a shell interface, right? Which, as you can see over here, it has all of this thing, the ls command from Linux, right? lscpu over here shows that, once again, this is also a quad, that is a 4-core Xeon processor, and in this case the amount of memory that this processor has is 6 GB, right? So does it mean Replit is better because they have 26 GB? No. I mean, these are all meant for small applications in any case, right? They can scale when required. And the point about glitch is, rather than focusing only on the development part of it, they also provide you some capabilities for how you could have an app always on, for example, right? And in some sense, they are trying to go in a slightly different track than what Replit is doing. Replit is focusing mostly on shared development, education, things of that sort. Having said that, they might also start providing facilities where you can actually have it always on and various other kinds of deployment options. Glitch is trying to focus more on developers and how they can share development of an app and actually deploy the basic starting point of an app. Okay. Now, in both of these cases, what is the platform that they are providing? They are taking care of the Linux server for you. They are taking care of the networking, data center, all of that part. So, at some level, it looks as though what they are doing is infrastructure, but they are also providing a platform in the sense that they have already installed Python. They have installed certain versions of Flask, right? They give you starter templates that can be used in order to get started creating an application. And on top of that, the web server, right, which automatically provides that URL for you that allows you to connect and see what the output is going to be, is also taken care of by this same Replit or Glitch, right? So, all of that part of the software infrastructure is also taken care of by them, which is why when you combine things, right, I mean, you look at overall, you have infrastructure, which is the hardware, you have some part of the software, which is the web server, the Python version, the other dependencies that are required internally, all of those are already installed for you, right? And what you have is a platform that has been provided. Okay. Now, both of these are focusing more on the development aspect. What I mean by that is they give you a nice interface whereby you can edit files directly in the browser. They also provide some mechanism whereby you can connect to it using, either a version control system, right? Or directly, download all the files, edit them on your local machine and then push it back up. Okay, so that can also be done if necessary on these kind of platforms.